So now let's talk about what is regression analysis. Regression analysis is basically a statistical technique that is used to determine the statistical relationship between two or more variables is that has to determine whether a change in a dependent variable is associated or not with a change in one or more of independent variables. When we are just analyzing one independent variable, we are talking about the most elementary regression model that is called simple linear regression. In this model, we will find a single numerical independent variable x is used to predict the numerical dependent variable y. We can see this is the equation for simple linear regression model. Y is representing the dependent variable. Beta 0 represents the y-intercept for the population. Beta 1 the slope for the population, and the e at the end represent the error in every y observation. Here we can see how it looks like when there is a relationship between y, the dependent variable, and x, the independent variable. We can see some scatter plots. The first two represent linear relationship. All the dots outside the line represent a positive and a negative relationship, while the two scatter plots on the right represent curvilinear relationship, which means that the linear simple relationship will not apply here. So in the case we are talking about more than one independent variable, it's not called linear simple regression anymore. It's called multiple regression model. And we are assuming here that there is a linear relationship between each independent variable and the dependent variable. We have the same one dependent, that is y, with the zero interception between the slope of the coefficient of x1 holding other variables constant. When we are interpreting this coefficient, we need to consider that all the variables are constant when we are interpreting the coefficient, every coefficient. Okay, so this is the same with beta 2 is the slope coefficient of the variable x2 when all the variables are constant. And we have the bk is the slope coefficient of xk holding all the variables constant, and last one is the e. It's the same, represent the same the random error and y for every observation, and thus are include all these variables that we haven't considered in our model is represented in the error. When interpreting one of the slope and multiple regression model, we should take into account the effect of the other variables. So the regression analysis model has some assumptions that we need to consider. The first one is normality. And we use the normality graph and regression output to test how normally distributed is our data. Also, we have another assumption, metric data, but it depends on measurements, and we're making sure just the variables are measured on a least and interval scale. Linearity as well. We use scatter plots like we saw in the pictures before, like few seconds before. This is just to recognize what kind of association this independent variable has between them. So if it's linear, the relationship is a straight line. So it's the only way we prove that there is linearity. Another assumption we are taking into consideration for this regression linear model, we have homoscedasticity at each level of the Pareto variables. The variance of the result should be constant. Residual graph in regression, it could be a lot of help to determine the homoscedasticity. And we have multicollinearity. There should be not very high or perfect relationship between the Pareto variables. And we just can use a test of IVS to determine the multicollinearity. And we have now an example to see how can we apply in a real case the linear regression model and what is this for. So here we have a company called Red Bull, and we are just analyzing the data we have. So let's just understand that this company is spending the money on different channels, different marketing channels for the past 100 weeks. So they are actually spending across a lot of platforms: Twitter, Vine, apps, Facebook, Instagram, YouTube, and TV. I think most of us has this social media apps, and they would like to simplify their marketing mix strategy. They would like to understand which channel is given the positive effect in their sales and which one is not giving a good effect on the sales results. The absolute here is just to understand which channel are associated with higher sales and which marketing mix spend option they should try next. So in this regression model, it's a multiple one because we have more than one independent variable. We have six independent variable, one dependent variable is y, and the independent is x1, x2, x3, x4 is 5, where x1 is spending on Twitter, x2 is spending on band apps, x3 is spending on Facebook, x4 is spending on Instagram, x5 is spending on YouTube, and the other is spending on TV. And y is represented by cells. So here the key questions that we need to answer after doing the linear regression model, in this case the multiple regression model, is does the spending on advertisement explain any variance in the sales? How much of the variation in the dependent variable is explained by the model? What are the unique contributions for each of the marketing mix channels to predicting sales? So here we are going to start using some, we can use RStudio as well, but because this is a little bit simple in this example, we're going to use Excel. So it's very easy, you just need to go to Data tab and then choose the analysis group, Data Analysis. When you click on Data Analysis, you need to look for regression and then OK. Once you click on OK, you will have this small box on your screen where you need to select the input y range and the input x range. So, and then if you have selected levels or titles of your data, you need to tick on levels like the number 3 that you are seeing here. Also, you need to select the output option. You can just put the results of your regression analysis in in a new worksheet, or also in the same one that you are working now. So you can just select the output range. What you want to see your result, just select the cell, and you will see after you put it OK, you will see the results. Also, don't forget that the confidence level that we are using now is 95%. So mostly we are going to use 95%, but also it could be 98, it could be 90 and others. So just be careful and just ask when we are going to consider 95% or not. So here we have the result that was given by the Excel data analysis. We have here the coefficients, we have the standard error, we have the t-stat, we have the intervals, number. So this is very important to understand the interpretation of the coefficients. Yep. First of all, we need to pay attention to which of these coefficients are the highest and the lowest. So it's really easy to recognize here that the lowest uh, belongs to YouTube with negative sign, right? 2.72. And the highest one belongs to Instagram, right? And it's positive, so it means that it's making a positive effect on sales, while YouTube's just making a negative effect, which is not what we are expecting here. So another important point, remember that here, because we're working with sample data, we need to work and do a t-test to see how significant is every coefficient here. So we just pay attention here to the p-value. So in the column 4, here just need to compare every number with 0.05, because remember we are considering the confidence levels of 95% and the significance level of 5%. That's why you need to compare all the p-values with 0.05. So considering the first one is higher than 0.05, which makes this coefficient no important for the model. Another one we have 0.66. Okay, so what is important here is that it is higher than 0.05, which means that this coefficient is not significant. We cannot reject null hypothesis.